Welcome back, folks. So today we're going to be putting a new case around my power supply here. I've had this thing for 3 or 4 years at least. Served me very well. But the issue is it's just too much jank enclosed in this little cigar box. So what I've decided to use instead is this old Dewalt case. That way it'll be portable, and I'm going to use 2 different supplies. One's the regular AC from a laptop like I'm using now. The other one is a 12 to 24 volt buck converter, so it's DC to DC. So when I'm out working on cars in the field, I can just plug this right into the battery and get 24 volts DC to play with. Give you a quick little tour of the inside of this thing. It's a pretty clean layout. Not exactly name brand parts. You know, Dave Jones might not consider it a Bobby Dazzler, especially not with these caps just flapping around in the breeze. And I mean, ECD, well, it's good enough for me. Here's a very crude drawing of what I want the face of the case to look like. You'll have 2 switches. You can choose between using the AC coming in or the DC coming in. And then I have 1 switch that'll activate some relays to reverse the current going to these binding posts for the output. So, first thing I gotta do, figure out how big of a hole am I gonna cut in this case. So what I've come up with is 71.5 mil by 39 mil. So before I start making the cuts to mount this, I want to totally remove this Dewalt label, so I'm using some goof off and some paper towels. Alright, so I've successfully transferred that label to these 2 paper towels. So the next thing I need to do is mark out where I want to mount this unit and cut the holes for it. Now when it comes to the physical placement of this thing, I mean, there's so many different ways that we could achieve this. Could just pull out the calipers, make a couple marks. Same thing with a ruler, you know, just put a couple dots where it's gonna go. And this is nice because I could measure from the edge to each side, and then once you get these 2 measurements the same, you know that the unit's in the middle. But I like things being a little more fast and loose, so I've cut this template to the same dimensions as the power supply unit, and now I can just take this and move it around like, does it look good here? Maybe I don't want it where I had originally planned. Maybe I want it over here. Of course, I'm going to stick with the original plan. Now, the importance of this shouldn't be overlooked because the placement of this is pretty critical. I mean, I want to be able to update this. You know, I might want to add features later on, so I'm going to need to have empty space. Alright, so let's pop our template on. Put a couple dots. Pull this thing out of here. Now, at this point, if you were concerned, you could take some measurements. You see from the bottom right-hand dot, it's about 11.5 mil to the top edge. So I'll come over here and put this dot at 11.5 mil. And look at that, the zero is right in line with the top edge. So this must be in center side to side. And just in case you're wondering, I can see the black dots on top of the black plastic. That's one little trick. Whenever you're doing fast and loose measurements like this, I always try and cut on the conservative side. And that way, when I'm done, if the hole's too small, I can just use a file to make it that little bit bigger so the thing fits. Because if you cut too big, well, then that's it. It's too big and there's nothing you can do. So, there you go. I mean, just at one glance, you can kind of tell that it was cut from a template and not pre-measured, but that's alright. It might be an ugly hole, but the bezel hides all our sins. Alright, so moving swiftly on, we now need to add the switches. Alright, so I've decided I'm going to mount the switches side by side like this. So to mount them right in the center, we just need to measure from the edge of the case to the edge of the bezel. Since 11 mil, what's half of 11? 5.5. So we just make a dot right at 5.5. And so now that we've divided the distance from the power supply to the edge of the case right down the middle, we can go ahead and divide it in halves again. So half of 5.5 is 275. So we'll put a dot there. And on this end, we can just go 1, 2, 75. Put a dot there. Whoops, I did 225. And this is 275 right here. Now we have our 2 midpoints for each side. And now after all that, we measure the length of this bezel, which is 4 mil, nice and easy. Come back to where we made our center mark and divide 4, so that's just going to be 2. Now that's the center of this square where we're going to mount the switch. Now do the same thing over here, and we've got our 2 center points. Now you just choose an appropriately sized drill bit. I think I went one step too many on this side, but that's alright. They'll all look the same with the bezel on. Now originally, I was going to put binding posts down here on the bottom, but I can't find the binding post that I was saving for this project. So I'm moving on to connectors. I have some EC5 connectors, so my thought is to mount it vertically, just like this, right at this edge there. So I'm going to drill a couple holes in the case, and I'm going to epoxy it in place. I'm just going to eyeball this one. Alright, so I've landed on using this 12 gauge wire. So I'm going to take the distance from the power supply unit to where the connector is going to be, and I'm going to double that. So in lieu of using ferrules, I like to just tin the end of the wire. Then the other end, I'm going to solder into these pins for the EC5 connectors. That's one, now I've got to do the other. So now that I'm done soldering these pins on, it's time to drive them into the actual connector itself. Normally I'd use a punch to drive these in, but this will work just fine. There we go. I've taped down this wire so that this kind of wants to be in this location. Now I'm going to take some of my favorite adhesive sealant, and at first I'm just going to be putting some back here on the base, and then once that cures I'll go around the outer perimeter. Alright, so that'll do for now. And so as soon as that first bit cured, I added some around the edges, let that cure, and now I'm going to leave it as it is and continue on with the project, and later on in the future I'll finish this off to look a little bit better. So now I've affixed my output leads to the connector for the power supply, and since I've had this for a few years and I ended up breaking the tabs off on here, so to get around that I'm going to zip tie it in place. Alright, so you see I've drawn them all tight up against the edge, and then I push from the outside to make sure it's flush, while at the same time drawing these as tight as possible. Alright, so now that that's been secured in, the next thing for me to do is take care of the power going to it from the 2 power supplies. Here's the one that runs on AC, as you can tell. It's 20 volts, 4.5 amps. And here's a boost converter for DC. As you can see, you put in 9 to 16 volts and you get 24 out. Only 2 amps though, so I'm definitely going to be replacing this in the future. Alright, so as you can see, here's the AC converter and the DC to DC boost converter. And the way I'm going to wire this up is I'm going to bond their 2 grounds together and make it one wire going into the back of the power supply. And so the positive from each one will go to each one of the switches separately, and then both the outputs of the switches will be bonded together as one lead going into the power supply. First I'm going to make a short piece of wire with 2 eyes on each end to bond the 2 positive sides together. A little something like this. Next I'm going to make a lead go from the switched side to the positive in. Alright, so now that that's installed, I can move on to doing the ground lead and the 2 leads in from each power supply. So as I may have mentioned earlier, I want to upgrade this in the future. So my plan is to just straight up squeeze it right in there. And then I'm going to drill a small hole in the side of the case here, and I'm going to cut this cord so it'll fit through, and then connect it inside. That way, in the future when I upgrade this, I can just make the hole bigger for whatever kind of connector or outlet I'm going to put here. So I believe if I just pin this down here, that'll be just fine. So let's say I'll cut the wire right here. Perfect. And then... Alright, so this video has been going on long enough, so what I'm going to do is just finish installing this AC adapter, get everything working. Alright. So now I've got this all wired up. This is going to be my stopping point when I install the boost converter, and I'm going to install a fan and a bunch of other upgrades. Those will come in a second video. Alright, so now that everything's wired up, it's time for me to finally install the AC connector right here on the side, and then we'll be good to go. So you can see the AC power adapter has a non-polarized receptacle on it. I have a non-polarized plug right here. Now what I'm going to do is drill a hole no bigger than this size of the cord, so I have to cut this. Now as to where to drill the hole for this, I'm just going to say, well look, this is about 2 inches roughly, so 1 inch is going to be the halfway point, and this is a straight shot back to the power pack, so that's where I'm putting it. Alright. So a little on the big side. I ended up going with 5/16. Now let's hook these back up. And there we have it. It's all installed, ready to rock and roll. Alright, so this switch is for the future when I install the buck converter. This is for the AC power, so let's test it out. I threw together these quick leads for the output. Alright, so it's all set. First thing I'm going to use to test it is one of these pre-built ZVS drivers. I just got it hooked up to a flyback transformer. Now if you come over here, you'll see I've got the voltage set to 12 volts with a maximum current limit of 5 amps. It's probably not even going to get close to that. Let's try it out. In the future, I'm going to do the current reversing, adding the DC buck converter. I want to add a power button so that I don't have to wear out this little soft push button, and fans, and a whole bunch of other stuff. Alright folks, well that does it for this project. Next time, we're going to take an old TV I found on the side of the road, pull some components out of it, make an audio amplifier, and a whole bunch of other stuff. So if that sounds interesting, maybe flick it, twist it, bop it, and we'll see you next time. I think I'll make the hole about that big. And I like it.